Okay, so welcome back. Um, we're at the second part of lesson number one for cost concepts and design economics. In this lesson, or in this part, we'll discuss the general economic environment concepts about the economy or engineering economy. There are numerous general economic concepts that must be taken into account in engineering studies. In broad terms, economics deals with the interaction between people and wealth, and engineering is concerned with the cost-effective use of scientific knowledge to benefit humankind. This part introduces some of these basic economic concepts and indicates how they may be factors for consideration in engineering studies and managerial decisions. The first concept is about consumer goods and services. The goods and services that are produced and utilized may be divided conveniently into two classes. Consumer goods and services are those products or services that are directly used by people to satisfy their wants. Food, clothing, homes, cars, television sets, haircuts, opera, and medical services are examples. The providers of consumer goods and services must be aware of and are subject to the changing wants of the people to whom their products are sold. Producer goods and services, on the other hand, are used to produce consumer goods and services or other producer goods and services. Machine tools, factory buildings, buses, and farm machinery are some of the examples of producer goods and services. The amount of producer goods needed is determined indirectly by the amount of consumer goods or services that are demanded by people. However, because the relationship is much less direct than for consumer goods and services, the demand for and production of producer goods may greatly precede or lag behind the demand for the consumer goods that they will produce. Okay? So that's the difference between consumer goods and services and producer goods and services. Next concept is about uh, the measures of economic worth. Okay? Goods and services are produced and desired because they have utility. No? Utility means the power to satisfy human wants and needs. Therefore, they may be used or consumed directly, or they may be used to produce other goods and services. Utility, as we define, is the most commonly measured in terms of value. Okay? Utility is most commonly measured in terms of value, expressed in some medium of exchange, such as the price, we call it price, that must be paid to, to obtain the particular item. Okay? So, much of our business activity, including engineering, focuses on increasing the utility or the value of materials and products by changing their form or location. Uh, Therefore, let's say iron ore worth only a few dollars per ton significantly increases in value by being processed, combined with suitable alloying elements, and converted into consumer products such as razor blades or rebar, uh, can increase its value. Similarly, snow, for example, a snow worth almost nothing when found in distant mountains becomes quite valuable when it is delivered to uh, or when it is delivered in melted form several hundred miles away from the dry cities. So this is the concept of measures of economic worth. Okay? So again, let me emphasize that utility, the power to satisfy human wants and needs, is commonly measured in terms of value expressed in some medium of exchange uh, as the price. Okay, so that's it. Next concept is about price demand or necessities, luxuries, and the price demand. Goods and services may be divided into two types. First, necessities and luxuries. Obviously, these terms are relative because for most goods and services, what one person considers a necessity may be considered a luxury for another. For example, a person living in one community may find that an automobile is a necessity to get to and from work. If the same person lived and worked in a different city, adequate public transportation might be available, and an automobile would be a luxury for him. For all goods and services, there's a relationship between the price that must be paid and the quantity that will be demanded or purchased. The general relationship is depicted in the figure at the right. So, the price that is being paid, that must be paid, versus the demand, okay? The quantity that will be demanded or purchased. So, uh, uh, as we can see, as the selling price per unit of a particular product or service is increased, okay, as we increase the selling price, there will be less demand for this particular product. Okay? And as the selling price is decreased, the demand will increase. So low price, high demand, high price, low demand. The relationship between the, the price and the demand can be expressed in a linear function. So we will discuss that in the next slide. Um, so let's say the price is equal to a specific constant minus uh, another constant or the slope times the demand. Okay. So where the first constant is the intercept on the price axis and the next constant is the slope. It is the amount by which the demand increases by each unit of T. So before we go to the details of this price and demand, uh, let's first discuss competition. This is another concept to be taken into account, um, competition. Because economic laws are general statements regarding the interaction of people and wealth, they are affected by the economic environment in which people and wealth exist. Most general economic principles are stated for situations in which perfect competition exists. Perfect competition occurs in a situation in which any given product is supplied by a large number of vendors, and there is no restriction on additional suppliers entering this market. Under such conditions, there is assurance of complete freedom on the part of both buyer and seller. Perfect competition may never occur in actual practice. Why? Because a multitude of factors that impose some degree of limitation upon the actions of buyers and sellers, or both. However, with conditions of perfect competition assumed, it is easier to formulate general economic law or general economic laws. On the other hand, we also have this monopolistic competition, or sometimes we call this monopoly. Um, we can say that a perfect monopoly exists when a unique product or service is only available from a single supplier. And that particular vendor can prevent the entry of all other competitors into the market. So that is the meaning of or the definition of a perfect monopoly. It exists when a unique product or service is only available from a single supplier, and that particular vendor can prevent the entry of all others into the market. Under such conditions, the buyer is at the complete mercy of the supplier in terms of the availability and the price of the product. While these perfect monopolies do exist, they are rarely uh, occur in practice. Why? Because first, few products are so unique that substitute cannot be used satisfactorily. And second, governmental regulations prohibit monopolies if they are unduly restrictive. So those are the reasons why perfect monopolies rarely occur in practice. Okay, so let's move to this concept about total revenue function. The total revenue, let's say TR, that will result from a business venture during a given period is the product of the selling price per unit, let's say P, and the number of unit units sold. D is the demand. Okay? If the relationship between the price and demand is given by the equation as we discussed earlier, that is P is equal to A minus B D, we can say that the total revenue is the product of this function times the total demand. So in this case, TR is equal to AD minus BD squared. From calculus, the demand that will produce a maximum total revenue can be obtained by solving the derivative of the function. Okay? So, and equate it into to 0. So therefore, when D is equal to A over 2B, it is the point wherein uh, this demand will produce the maximum total revenue for a particular business venture. It must be emphasized that because of cost volume relationship, most businesses would not obtain maximum profits by maximizing revenue. Accordingly, the cost volume relationship must be considered and related to revenue because cost reductions provide a key motivation for many engineering process improvements. Okay. In this slide, we'll discuss the basic relationships between costs, volume, and the break-even point. Again, let us emphasize that because of cost volume relationships, as we are going to discuss, most businesses would not obtain maximum profits by maximizing the revenue. So however they maximize the revenue, they would not obtain maximum profits. Accordingly, the cost volume relationship must be considered and related to revenue. Why? Because cost reductions provide a key motivation for many engineering process improvements. Okay. So here we have an illustration of the combined cost and the revenue functions and the break-even points as a function of volume and their effects on the typical profit of a business venture. So this line or this curve represents our total revenue curve as we have discussed earlier. And then we also have this fixed cost, okay, a horizontal line here. When added with our variable costs, we then obtain this line we call as the total costs. The intersection between the total cost and the total revenue, these 2 points, is what we call the break-even points. These points tells us that the total revenue is equal to our total costs, in which a business venture does not have any profit. So we call it break-even points. So our first relationship, as discussed, we have this total revenue, which is equal to AD minus BD squared. Meanwhile, we have our total cost equal to our fixed cost plus our variable cost. So fixed costs remain constant over a wide range of activities, but variable costs vary in total with the volume of output. Therefore, at any given demand, our fixed cost or variable cost is equal to cost per unit or variable cost per unit multiplied by the demand. Okay, so for our first scenario, the demand is a function of price. Whereas in the next scenario we are going to discuss, we will assume that price and demand are independent with each other. So in this first scenario, when the total revenue as depicted in this figure and total cost given by these equations are combined, we then obtain these break-even points. So our profit or loss, if negative, is equal to our total revenue less or minus our total cost. So that's pretty obvious. If we are going to combine or to use these variables on hand, the total revenue, total cost, variable cost, our profit will then be equal to negative BD squared plus A minus C V times D minus the total fixed cost. Okay, so for us to determine whether we have a profit or loss, so we then check for the conditions for profit. So first, we'll have to check the difference between our A and the unit variable cost should be greater than zero. Okay, so this particular variable in our or expression in our equation of profit should be greater than zero for us to have a profit. Of course, our total cost should be greater than our total revenue should be greater than our total cost so that we will have uh, a positive value for a profit. Then we would want to determine the demand for the maximum profit, right? So the demand for maximum profit is, as discussed in the earlier slide, is equal to A minus the unit variable cost all over to B. Okay? And our break-even point, or should I say break-even points, is given by this expression. Okay? Negative A minus C sub V plus or minus the square root of A minus C sub B squared minus 4 times negative B minus negative fixed cost all over negative 2B. So these four are the formulas we are going to use in the uh, next example in illustrating the relationships between costs, volume, and break-even points. So let's take a look at this example. Um, a company produces an electronic timing switch that is used in consumer and commercial products. The fixed cost C sub F is $73,000 per month, and the variable cost is $83 per unit. The selling price per unit is given by the equation P is equal to $180 minus 0.02 D based on our price-demand relationship. For this situation, determine the optimal volume for this product and confirm that a profit occurs at this particular demand. Find the volumes at which break-even occurs. That is, what is the range of profitable demand? So, in this problem, we are going to determine the optimal volume for this product. And so, we are going to solve for the demand, maximum demand, and confirm, we will confirm if there is a profit at this particular demand. Next, we will have to find the volumes wherein the total revenue is equal to the total cost. Uh, okay, so for our solution, so first, the demand for maximum profit is given by the formula A minus C sub V minus all over 2B. So for A, that will be 180 as given in the problem. For C sub V, it is the variable cost $83 per unit, and 2B, where B is 0.02. Alright? So substituting the values, we then have the demand for maximum profit equals 183 minus $83, or 180 minus $83 divided by 2 times 0.02, which gives us 2,425 units per month for us to have a maximum profit. All right, that's the optimal volume for this particular product, electronic timing switch. Let us check if uh, or confirm that this profit occurs at this particular demand of 2,425 units per month. So what we are going to do is to check the conditions for profit. First, let's check if A minus C sub V is greater than 0. Our A is equal, and of course, the next condition should be the total revenue should be greater than our total cost. For the first condition, we have $180 minus $83 and it is equal to $97. Of course, $97 is greater than 0. Therefore, this condition tells us that 2,425 units per month uh, confirms that a profit occurs in this particular situation. Next, let us check if the total revenue is greater than our total cost. So the total revenue is given by uh, the formula $180 times our demand. So that's AD minus BD squared. Okay? So that's $180 times 2425 minus 0.02 times 2,425 squared. It should be greater than our total cost, which is $73 minus $83 times 2,425. Therefore, in this case, a demand of 2,425 per month results in a maximum profit of $44,612 per month. Okay? So for our break-even points or break-even point, we are going to use this formula in solving our break-even points. Okay? So, of course, let us determine our A. A will be $180. C sub V is 83. B is 0.02. C sub F is $73 per month. B is 0.02. Substituting these values in this formula gives us two break-even points. First break-even point is that the, the company shall sell or produce 932 units per month so that the total revenue is equal to the total cost. And another point is that the company should produce 3,918 units per month uh, so that the total revenue is equal to the total cost. Okay, so the volumes or the range wherein the company has profitable demand is between 932 units per month and 3,918 units per month. So, in the next scenario, our second scenario, it is when the price per unit for a product or service can be represented more simply as being independent on demand or versus being linear function of demand as assumed in the first equation. So, and it is greater than the variable cost per unit. In this case, a single break-even point results. So, this point here. Okay. At this, um, under the assumption that demand is immediately met, okay, the total revenue is equal to the price times the demand. Okay. If this linear relationship for costs are to be used in a particular model, then we can say that the price is independent of demand. Okay, so we have two scenarios in determining our break-even point. So to summarize, market competition often creates pressure to lower the break-even point of a particular product, service, or an operation. The lower the break-even point, the less likely that a loss will occur during the market fluctuations. So the lower the break-even point, the less likely a loss will occur during market fluctuations. So also, if the selling price remains constant, a larger profit will be achieved at any level of operation above the reduced break-even point. So there are two uh, key concepts in this particular uh, um, lesson. You lower the break-even point, make your selling price constant or increasing. Therefore, the gap between these two variables uh, increases, therefore increases the profit of a particular level of operation. Okay, so remember that in engineering economics, for a market competition that creates pressure to lower our break-even point and increase our selling price. Okay, so that's it. Thank you for listening in this second part of our lecture number one. Okay, thank you.